Today we will start our discussion on small sample test, and we will start our discussion on t-test. So what is a t-test? A t-test is also known as a student t-test. So it is a statistical analysis technique that was developed by William Shelley Gosset in 1908 as a means to control the quality of dark beers. So friends, you know that what is this x? Suppose if x follows normal mu sigma square, then the value of z follows normal 0 1. And what about z square? Z square is a square of standard normal variate, and square of standard normal variate is a chi-square variate with 1 degrees of freedom, and summation z square is chi-square with n degrees of freedom. So this is same as what? So this is same as summation xi minus x bar square divided by sigma square follows chi-square with n minus 1 degrees of freedom. At the same time, we can also write it as n minus 1 s square divided by sigma square. So sigma square is the population variance, and this s square is sample mean square, and it follows a chi-square distribution with n minus 1 degrees of freedom. So if you know these results, then we can easily understand what is a t-variate. So suppose if you take z and v are two independent random variables, whereas this z is a normal 0 1 and v is nothing but our this result. So you know this result. So n minus 1 s square divided by sigma square follows a chi-square with n minus 1 degrees of freedom. Then we can, if you make this arrangement, so that means t is equal to z upon square root of v divided by n minus 1 is said to follow a t distribution with parameter n minus 1. See, what is important in this case is z and v should be independent random variables, whereas this this z and v are the functions of the data. Z may be sensitive to the alternative hypothesis, that is its magnitude tends to be larger when the alternative hypothesis is true. And what is this s? S is the standard error of the mean. So it is a scaling parameter. So it is divided by s, and normally this v represents this s. See, what is this v? V is s square n minus 1 divided by sigma square. So which follows a chi-square with n minus 1 degrees of freedom. So this s is a standard error of the mean, which is a scaling parameter, and that allows the distribution t to be determined. So what is this n in this case? So n represents the degrees of freedom, and the degrees of freedom are nothing but the number of independent variables. So how many independent variables are there? So that is represented by n. So now we will start with some tests based on t distribution. So there are few tests based on t distribution. So like test for one sample t test. So test based on two samples, whereas the size of the samples are unequal, so that is unpaired t test. So one is a if both the sample sizes are same, so that is a paired t test. And so there such tests are there. We will start with our discussion one by one. So today we will discuss this test of population mean h naught mu equal to mu naught. So there may be a question like this. So describe small sample test for testing h naught mu equal to mu naught against h1 mu which is not equal to mu naught. So what are the assumptions of this t test? So the assumptions of one sample t test are, so x bar follows a normal distribution. So x bar follows a normal distribution, and with mean mu and variance sigma square upon n. The second is s square n minus 1 sigma divided by sigma square follows a chi-square distribution with n minus 1 degrees of freedom. This assumption is met when the observation used for estimating this sample mean square come from a normal distribution. So that means all these the parent population should be normal. So that is the basic assumption for t-test. And one more assumption which is needed, that this z and s are independent. So that means this s which represents v represents this s, therefore we can say that z and v are independent. So suppose if the value of sigma square is known to us, then it is nothing but a large sample test. So that means that z test is z is equal to x bar minus mu divided by sigma upon root n. So only the problem arises if the value of this sigma square is unknown to us. And suppose the value of sigma square is unknown, so we have to make this arrangement. So that means z is equal to, we know that z is equal to x bar minus mu upon sigma upon root n, follows normal 0 1, and this v is nothing but summation x minus x bar square divided by sigma square. And again z and v are independent. So what about this t? So t is, we know that t is nothing but z divided by, so what is this t? T is nothing but z divided by square root of v upon n minus 1. So take this t as this value, and if you put the value of z and v in this equation, so we will be getting this value, and that is nothing but x bar minus mu divided by s upon root n, where this s is nothing but my estimated value of population standard deviation. So this is s is nothing but square root of this value. So s is equal to square root of summation xi minus x bar square divided by n minus 1. So suppose if you put the value of mu is equal to mu naught under the null hypothesis, see any testing procedure having 4 steps. So the first step is we have to build up the null hypothesis, so set up the null hypothesis. The second one is we have to find out the test statistic. In this case, since the test is related with small sample, so we are taking this t as a test statistic. So that is second step. The third step is related with the critical region, and the fourth step is our conclusion. So under h naught mu is equal to mu naught, so this follows. So that means t is equal to x bar minus mu divided by s upon root n, follows t distribution with n minus 1 degrees of freedom. So now, so this, what is this x bar? So x bar is equal to, so my x bar in this case is, x bar in this case is the sample mean, and the sample mean from the sample x1 x2 up to xn, and s is the standard error of the mean, sigma cap is my estimate of the standard deviation of the population, and mu is the population mean. So what is my test procedure? Now the test procedure becomes, the alternative hypothesis in this case is, so if the test is two-tailed, then this is my alternative hypothesis. So what is the alternative hypothesis? So mod t n minus 1 is greater than or equal to t n minus 1 alpha by 2. Alpha is my level of significance. So if my test is right-tailed test, then this t n minus 1 should be greater than t n minus 1 alpha, and if it is a left-tailed test, so mu is less than mu naught, then t n minus 1 less than or equal to minus t n minus 1 alpha. So this is the critical region where we can divide the data into acceptance region and critical region. And what about the conclusion? So conclusion is, if the calculated value of t is greater than t, h naught should be rejected, otherwise accepted. So this is all about the t small sample t test, and this t test is related with one sample. So therefore it is also called as one sample t test, and this one sample t test is given by the William Gossett with he developed the t statistics and published it under the pseudonym of student. So this is all about the t test, one sample t test. Thank you very much.